It's working. So, good evening, everybody, once again. We've often heard about the downside of, plastics. However, Mr. Sameer Joshi very well showcased us how we can make best use of it. Likewise, it is same with, EV vehicles. So we can very well say that how plastics are now revolutionizing EV batteries, thereby enhancing its durability, safety, and also its overall sustainability. So our next panel explores more about how plastics are used in electric vehicle batteries. So my first question is to Mr. Diwakar Gokhale. Sir, I would like to know how plastics in thermal management systems for EV batteries are used, and what are the benefits of that?
Okay. Electric vehicle battery primarily has, let's say, from plastics point of view, some important components, typically top cover, bottom cover, cell holders, and sometimes depending on the battery design, it can have different designs of cooling. So, from thermal management point of view, plastics material deliver different properties, different values, but the biggest advantage or two biggest advantage plastic material gives is light weighting, which is very, very important for electric vehicles, number one, and secondly, the design flexibility, because typically with metals, you still have a lot of limitations with very complex designs and also manufacturing technology behind it, and these are the two biggest advantages we bring. Third may not be that big, but of course one important topic is recycling of parts, and which is very easy in plastic materials. We talked about mono material design since morning, so if battery design is done with mono materials, then recycling is even much easier, because then you are not dealing with a lot of polymers. So I think to get the conversation going, maybe these are some points I would like to mention. This is the advantages we bring. Yeah.
Right,
Yeah,
sir.
I will add one or two more point about it. The density, the output charge, because we will have a compact use of the battery. It will help on the plastics when we use aluminum and other material which will not be very density friendly. So this is very high density friendly material which will give us a lightweight and everything, and you can have more charge and more power on that battery. That's another.
Right, sir. So now my next question would be, what challenges does thermal management pose, and how do plastics help to address them?
Yeah, but plastic will not actually help. Currently is very great difficulty to helping on the thermal conductivity. That's now that many material development is going on, then you can have a better thermal conductivity on the material. And another advantage of FR grade, which already there in that FR. So thermal conductivity, which is going on, and we are developing some of the products which will help us to develop better results, because currently we do a lot of thermal analysis to have the issues which we are facing currently on thermal side. But I hope very, very quickly we will come out with this problem, putting silicone and other material which will reducing the life, also reducing the increasing the problem and complexity on the system. So I think the plastic will help in very advanced level that will help on the thermal conductivity system.
Yeah, maybe I can bring a bit of good news. So at Covesto, we have done some developments, and we can show you a couple of samples at our table outside. So one thing is what Mukul already mentioned about thermal conductive materials. So we have thermal conductive grades in polycarbonates, which are either electrical insulating or electrical conductive. So it depends on how you are designing which part of your battery, number one. Number two, if the battery is liquid cooled, then we have developed certain grades that helps you to design a battery that enables a liquid cooling technology in you. And I can show you one example again on our booth, where you get a lot of design flexibility again with liquid cooling design, and these materials are resistant to the coolants that are typically used in the batteries. So in these areas we are working you also mentioned about FR, which is typically flame retardancy, which is very, very important. For any electrical vehicle, battery is a heart, and for battery, flame retardancy is at heart. So material that is flame retardant is very, very critical. And we have developed several levels of flame retardant grades, because every OEM, even for different models of the vehicle, same OEM but different model of a vehicle which has a different charge or different kilowatt hours, has a different flame retardant requirement, and that comes as a challenge or also opportunity for us to do something new. So we have developed FR grades which are FR V0 at different wall thicknesses. We talked about small, let's say less wall thickness articles for weight reduction or even design flexibility, and this can be enabled by using such materials. So we are very happy to work with either the OEMs or the battery pack manufacturers to discuss this. We are also able to help them with the part design, because we bring that material expertise from our side. We have the design capability on our side, and also give some guidance on tool design if required. Of course, a lot of companies in India have their own tool design capability, but coming from a design material viewpoint, we can do some more value addition. Yeah.
Right, sir. So since plastic is not sustainable, I'm sorry to say that it's not a sustainable material. However, what are the safety standards and regulations, in place for plastics used in EV battery components?
Okay. So, ARAI, the Automotive Research Association of India, and that has been looking very closely at the safety requirements, particularly to EV vehicles and the battery. So standards like AIS 156 or AIS 038, these are the standards that are very strongly implemented. And then there are versions 1, or let's say Amendment 1, Amendment 2, and recent Amendment 3. These has posed certain challenges to the e-mobility industry, to the OEMs, because they have to make their battery packs compliant to all these regulations. But fortunately, the regulations are very strict, the authorities are very strict, and unless this is confirmed, the compliances are confirmed, the vehicles are not produced or not allowed to be produced. So many companies have to redesign their BMS, the battery management system, and again, it's a joint work. So with the OEM, but with the battery designer and also the material manufacturer. So in between, for a few months, we had a lot of collaborative work together to help our customers comply with these regulations. So these are two primary regulations other than the standard ARAI regulations which are applicable for any vehicle. So you bring any new vehicle or any new system, I think most of the people in the room are aware that the standards are anyway to be complied. But on top of that, these two regulations are very critical. Yeah.
Yeah, other than that, all AIS standard or FMBS standards are well established, which we have to implement. And other than that, you can see if we use more plastics, we will have a reliable, you can say the results are available, and which will help to develop as per the standard. And if you see that the reliability on the plastics are very, very high current. And we are getting a lot of, when we use more FR grade, there is some, you can say there's some deficiency on the material flow. Those are there, but we are able to manage. Then again, V0, V1 category already there, we have to fulfill those requirements.
Right, sir. So how do plastics help in enhancing, the durability and lifespan of EV batteries?
Yeah, the durability, because the plastic is a very renowned, or you can say a popular material which having a very high durability, and they have proven in the last, let's say 30 years, people are thinking the metal is more durable material. Now, if you talk about it, the plastic is more durable than the metal. So we prove it, the plastic industry has proven that all the processes, manufacturing of the materials or plastic material with the different durability, it is actually, if you design your product very well, you will get better durability than other material processes which we are getting. So I believe that material properties are very, very, enhance the properties, and the durability is very high that nowadays.
You spoke very specifically on material properties. I would like to just add on. So as these regulations are becoming stricter, or the designs are changing, or new designs are coming, this also brings us a lot of new requirements from material point of view, whether it's plastic or whichever. Especially for plastics, then we have to work on specific properties of plastic to make it more durable. So we have a range of materials which have a very high CTI, which are required sometimes in powertrain solutions. So you cannot isolate only battery packaging for the durability of your vehicle or a battery. The battery management system or the connected powertrain is also equally responsible. So we look across this and then try to develop a solution together to work with this, so the matching powertrain solution or BMS solution like that.
Right, sir. As I mentioned, recycling of materials is one of the biggest challenges. Even our previous panel kind of, emphasized a lot about it. So, in fact, be it metal or be it plastic, recycling again is a challenge when it comes to EV battery. So what efforts are being made in terms to, improve the recyclability of plastics in EV batteries?
So recyclability, if you talk about the plastic is actually, you can say the 100% we can recycle it. But in terms of the recyclability of the battery and those other elements are still is a critical phase. We as a automotive industry, we have to work around it, how to mature enough and then do all segregation of the material. But battery itself is a very difficult, you can say that you have to segregate every elements from the battery and then only you can recycle. But in case of plastic, when we use metals and there is a welding and other elements will be added, then you can say the product will be complicated to recycle it. When we talk about plastic, you have a single plastic, you can segregate better way and then you can recycle as per their requirement.
I agree. And in fact, one of the OEM present today here, they have a team which is currently working on recycling of batteries. There are two ways of recycling batteries. One is actually, like Mr. Mukul Sharma mentioned, that you actually recycle the battery. The other one is you can repurpose the battery. Yeah. So if your battery has lost power, you cannot deliver the same energy, then you can use that battery for something else. So if you have a swappable battery, you take it home and use it in your home to run some appliance, or you can work.
The second life application.
Second life application. So this is another way, and that's also one of our topic, repurposing. So this is repurposing is possible. But yes, there are some companies, OEMs in India, and they have teams, and we are discussing with them quite actively to look at how can we develop an ecosystem to recycle the battery itself.
Yeah, one more point I can add, that if you want to see something on Google, you just type dw.com and you can find very good use of recycle or the low power efficiency of the battery, how Indian startups are using those batteries, and they are making good batteries and they're supplying to roadside vendors. They are running tube lights and those things in shops. So very good use. You can have a look on those things.
Absolutely right, sir. Since there's a related topic that I'm going to put up right now, which is on the environmental impact of using plastics in EV batteries, and how are they impacting its overall sustainability?
As such, whether the plastic is used in battery or any other application, it has no different environmental impact. So usage of plastic in electrical battery or EV battery has no additional or a different more or less impact on the environment. It is much similar. If we are able to reuse or repurpose, then we reduce the impact. So far, we have doing some projects where we are able to use the CQ range, the circular products also for battery packaging, where we have a PIR content or a PCR content. So far, nobody has come up to try and use it in their commercial vehicles right now, but we are ready with the product. So if anyone is willing to do some experimentation using this PCR content or PIR content, if our materials, we are willing to do it. So that is, again, going back to what I said, it doesn't create a new impact on the environment, but we are working on, can we reduce it like we are doing it with other standard automotive applications as such. Yeah.
Mr. Mukul, would you like to add in?
Yeah, that's the only thing which we can say, that because we are in the very start, the phase is very nascent start phase, you can say that we does not, currently we have to establish the product in the market. If we start doing the recyclability, adding more variables, will be difficult because we have a lot of challenge to give us the right product to the market. And in let's say in the next 5 years, I think we should control on virgin material or the right material rather than trying more variables so that it will create more problem for the system. So I feel that still 3-4 years we should target on the virgin material and then we go for the recyclability, because currently we in the system, if we see the battery pack, we can easily take out the plastic. If we disassemble the complete battery pack, you can remove easily and then you can do whatever you want on that.
All right, sir. So, are there any recent innovations in plastic materials and technologies, that have significantly improved the EV battery performance? Because range anxiety is one of the causes, one of the challenges. So, how it is helping in improving the overall performance of EVs?
So, yeah, for thermal conductivity is a very important factor, which we are working currently on how to release the heat as fast as possible, because if we use silicon or any other aluminum or the cooling system, which will require a lot of energy to solve the problem, and then built-in properties of thermal conductivity will help us. So which is we are working, so that it will you can say that save a lot of money and lot of you can improve the efficiency of the battery also.
Right, with this we conclude with our panel. Now I open the panel to the audience. So any questions?
Thank you. I had a question about plastics specifically for the EV batteries. What is it that the EV battery needs special from a normal battery to make it more safe? Because humans are going to ride in that car. So what kind of plastics and how is the whole safety of the battery inside the EV thought about? Maybe it's not related to the topic, but just since you are there, I wanted to pick your brain on that.
Yeah, so basically...
And the question is to both of you. Thank you. Both of you. Both of you.
Material point of view. For battery, if you go back before electric vehicles were even there, we used actually rechargeable lithium-ion batteries in the past as well in our laptops or other devices where we were recharging it. And those devices, including the cars or vehicles today, have the same challenge that when you are charging or using the battery, when it is discharging the power, it builds a heat. And that heat needs to be controlled. So in laptops, you have cooling fans, or there are multiple technologies. Same challenge we have with e-vehicle batteries, whether it's a two-wheeler, three-wheeler, four-wheeler commercial vehicle. So we are talking about managing the heat that is generated. Secondly, it's also a topic of thermal runaway. So when the battery is charged, when there are multiple cells in the battery, even one cell does a thermal runaway. So the temperature shoots in 1 or 2 seconds so high that the battery can catch fire and the whole vehicle can catch fire. And you would have seen or read
You've heard about those incidents
many times.
Yeah.
And these are the main concern areas from the safety point of view. Not going to extreme, if the battery continues to heat, the efficiency of battery is lost. So the delivery of energy on a consistent basis is not a straight line. It drops over a period of time. So that means you have to continuously charge or multiple times charge, which is not how it's supposed to run. So basically it's managing the heat and managing then the risk coming out of the heat if inevitable happens. To manage that, two main factors. One is thermal let's say resistant or heat resistant materials, and then the flame resistant materials. So these are two key requirements for battery pack, whether it's a top cover, essentially the cell holder. So cell holder is where it's like a frame where you have multiple cells. I can show you the part on our stall. So the cell holders are very important, but it's not only the material, and he can add, it's also how you design the part. So if you have, for a very simple example, if the tolerances are not designed precisely, if the gap between cell and the cell holder is too big, if the cell is shaking, and that can also cause multiple things in the battery. And in a vehicle, in a scooter, maybe it's 1 or 2 battery packs. In a car, multiple battery packs. The whole floor of a car is full of battery, and even commercial vehicles even higher. So the risk multiplies. So these are some factors that needs to be considered when we are designing elements of the battery and also the material selection. Yeah. And you asked what kind of materials, or from plastic point of view. So most commonly what we see today are typical PC-ABS flame retardant materials, but of course there are other materials, some nylons or some other thermoplastic materials are there. There are certain advantages of not going for nylons, and I have nothing against nylon because I have worked in that field also in the past, but every material has an advantage and a disadvantage. Yeah. What you get in PC-ABS is much more than what you could get in other materials. I can only say on a very generic term. Yeah.
Okay, thank you, thank you.
For this important thing, currently you can say that PCABS or any nylon material is on a high density materials, and the cost of the material also very high. So how to bridge between the material thickness, and if we talk about PP or any other material, we need a higher thickness on that, and the density will lose. So we are in that zone that how to reduce the density or the thickness of the material. Currently, let's say we have about 1 mm thickness or 1.2 mm thickness on a battery. You can say the shell between the battery to battery gaps, which is very important, how to reduce the gap and what material is suitable. So currently we are debating between the materials to materials and how to fit between it. So the FR is highly important, and the second will be the thermal conductivity or the runout, whatever is required, and the flowability of the material, which is also very challenging currently. If we are using ABS or PC-ABS, we cannot fill on a low thickness. So those are the challenge, and we are coming up with the new processes and material process.
One interesting because you come from machine manufacturing background, one interesting topic could be also, like he mentioned, everybody has a challenge to make as thin part as possible. And when you do that, all challenges are aligned to that, design, execution, molding, and piece-to-piece dimension consistency. Cells have a lot of high dimension consistency. They also give you certain tolerance. So if you're talking about cylindrical cell, which are similar to our pencil cells in the remote, TV remote or something, they look very similar. Yeah. So their tolerances are known, but plastic tolerance, you can design the component for a plastic tolerance. You can design the tool for plastic tolerance, but the delivery of the tolerance is coming from your molding. So molding, to say it's just one word, but all of us know it's just a word on the top. There are so many things behind. Yeah, expertise, experience, machines, tools, process, so many things. So this is something also needs to be considered. And exactly right, he said, these are the challenges. On one side, you want to do low density but high density energy, but thin parts. On the other side, the challenge of design and actually molding those parts consistently. Yeah.
Thank you, gentlemen.
Any more questions? Okay, so I think with this, we'll wrap up this session. Thank you again for being so receptive and so patient with our, all our panel sessions. Thank you so much.